Today we're going to review for our first half of our Chapter 2 test. We are focusing on functions, equations, and graphs. Our first learning target was to be able to identify functions. So we've given you two different forms of showing you data. In this first one, we're just giving you 4 different ordered pairs. The directions say to find the domain and range of each relation and determine if it's a function. Your domain, if you remember, are your x values. So we're going to go through and list all of the different x coordinates. So we have a 1, a 4, a -1, and a 2. For the range, we're going to list all of our y coordinates, 3, 5. Now the 3 we don't have to write a second time when it's repeated like that, and then the 6. Now, if it's a function, every x has to be paired with a single y. So if you look at your x's, you have a 1, a 4, a -1, and a 2. None of those are repeated, so this would be a function. Okay. In our second one, instead of giving you ordered pairs, we've given you a graph. This is a parabola. It's an upside-down parabola. Our graph does continue even beyond the coordinate grid that we're showing you. It's asking for whether or not it's a function and domain and range. When we have a parabola like this, our domain, our x values, would be all real numbers. You can use that symbol or just say all reals. Because for every x, even if we go over here to this x, if we go down far enough, we actually would hit that part of our curve. Our range, though, we have a cutoff. In this case, our y values, all of these y's are getting used down here, but once we hit the 3 up here, that's the highest we go. So our y values would have to be everything less than or equal to 3. To tell if it's a function when it's graphed like this, we would use the vertical line test. If we draw a vertical line anywhere in our graph, we only hit the graph in one spot for each of those vertical lines. So we'd say, yes, it's a function. And if you need to give a reason for that, we would say it passes the vertical line test. Question 3. Which point could not be a part of a function that includes these ordered pairs? For it to not be able to be in there, if it's a function, we're looking for an x that's already listed. We can't have a repeated x. So looking at my x values, I have a 3, a 4, a 5, a -2, and an 8. Could I have a 6 added to that set of ordered pairs? Yes, because I don't already have a 6. So that one would be okay. Could I have this point, a 3, -2? And that's where we have a problem, because we already have a point that uses an x value of 3. We can't have two different points that use the same x value. So B here would be the one that could not be part of our function and still have it be a function. All right, the second set of questions here, it says our learning target is I can evaluate functions. We're getting used to that function notation. Remember, this is read f of x. It's telling you that there's a function that's using x as the variable. And so if they give you this, they're saying evaluate that function when x is -3. So our function is something squared plus 5 times something minus 6. And they are telling us, let's evaluate that for -3. So we're going to plug a -3 in for our x's and simplify. So our value of our function when x is -3, we would have -3 squared, which is 9. We have 5 times -3, so -15, and then subtracting 6. So we are going to get -12. So f of -3 equals -12. Our second question asks us to evaluate the g function for x being a 1. And our g function is the absolute value of x minus 4 plus 7. So we are going to take that x out and we are going to replace it with a 1. So the absolute value of 1 minus 4 plus 7. 1 minus 4 is -3. When we take its absolute value, we get 3. add our 7, and we would say g of 1 comes out to be 10. From section 2.3, our learning target that I can calculate slope. Remember our equation for finding slope is change in y, so y2 minus y1, over the change in x, divided by the change in x, x2 minus x1. So looking at our y coordinates, we have an 8 and we have a 2. You can choose to subtract them in any order, but then you have to do the x's the same way. So I'm going to go 2 minus 8. Then I have to do the x's in the same direction, 5 minus that other 2. Simplifying, 2 minus 8 would be negative 6. 5 minus 2 is 3. Our slope reduces to being a negative 2. For question 7, we're going to subtract our y's, so 3 minus 3. Subtract our x's, negative 1 minus 2. We get 0 divided by negative 3, but 0 divided by anything is 0. For question 8, subtracting our y's, 7 minus 4. Subtracting our x's, 3 minus 3. And in this one is the one where we have a little problem. 7 minus 4 is 3, but in the denominator, 3 minus 3 is 0, and we can't divide by 0. So we say our slope is undefined. All right. All right, our next learning target is looking at writing equations for lines. We have 3 different versions. We have slope-intercept form, we have point slope, and we have standard form. The first question says to rewrite the equation into standard form. Standard form is where we have ax plus by equals c. Our x and y's have to be on the same side and our constants on the opposite side. So for this first one, I'm going to subtract the 1/4 x to the left side. I now have negative 1/4 x plus 2y minus 3 equals 0. Then I'm going to add my constant to the other side. So negative 1/4 x plus 2y equals 3. And then I want to clean up the fraction because in standard form we don't have any fractions or decimals. So we are going to multiply by a number that will get rid of the 4 that's in our denominator here, as well as our negative sign. So we're going to use a negative 4 and multiply through by that. Negative 4 times negative 1/4 gets us 1x. Negative 4 times 2y gets us negative 8y. And negative 4 times the 3 gets us negative 12. The next set of questions say to write the equation of the line with the given information in the indicated form. So we are told the slope is 1/2 and we want it to go through the point 4, negative 1. It says we want a final answer in standard form, but remember that's not the form that we have to start with. Since we're given a slope and a point, it makes sense to start with point slope form. So point slope form is y minus y1 equals our slope m times x minus x sub 1. And then we're going to plug in our values. So y minus our y coordinate of negative 1 equals our slope times x minus our x coordinate, which is 4. Subtracting a negative is really just adding, so y plus 1. Distributing, we get 1/2 x minus half of negative 4 would be negative 2. And then it's asking for standard form. So I'm going to go ahead and move all my constants to the right-hand side. I'm subtracting a 1. I have y equals 1/2 x minus 3. Then I'm going to get it to standard form where the x's are on the same side. So I'm subtracting 1/2 x over to the other side. I now have negative 1/2 x plus the y equals negative 3. To clean up a negative 1/2, we're going to multiply by a negative 2. So my final answer for this one will be 1x minus 2y equals 6. For question 11, we are given 2 points and we want our answer to be in slope-intercept form. So my first step is going to be to figure out the slope. Change in y, 5 minus 3, divided by change in x, 3 minus negative 1. Numerator becomes a 2, denominator is a 4. So my slope is reduced down to 1/2. Now, it asks for the slope-intercept form, but I'm going to start with point slope. So again, y minus y sub 1 equals my slope times x minus x sub 1. We said our slope has to be 1/2, and I can choose to use either point. I'll go ahead and use this first one, x minus the negative 1, and on the left here we'd have y minus 3. I'm going to clean up the right-hand side here, 1/2 times x. 1/2 times a negative negative, or a plus 1, is 1/2. And slope-intercept form is where we have y all by itself on the left side. So we're going to add this 3 over. So y equals 1/2 x plus, we get 3 plus 1/2. We typically don't leave mixed numbers in our equation, so we're going to go ahead and convert that to an improper fraction. 3 plus 1/2 would be 7/2. All right, our next question says to write an equation for the line, leave our answer in point slope form. This time it's asking for us to give an equation that is parallel to y equals 2x plus 1 and going through the point negative 2, 3. If it is parallel, we're going to use the same slope. So from this equation, I know that my slope is 2, and parallel lines always have the same slope, so I'm going to also use a slope of 2. Plugging it into point slope form, we'd have y minus our y coordinate, which is 3, equals our slope times x minus the x coordinate, which is negative 2. And then I would just clean that up a little bit. They want it in point slope form, but I would clean this up and say it's x plus 2. All right, question 13 asks us for a line that's perpendicular to this one. Notice that the equation this time is in standard form, so you are going to have to convert it into slope-intercept form in order to identify what the slope is. So we've got 3x plus 4y equals 8. We're going to subtract the x piece to the other side. Then I'm going to divide everything by 4. So we get y equals negative 3/4 x plus 2. 8 divided by 4 would be 2. So my initial line, my original line, has a slope of negative 3/4. My perpendicular line will need a slope that's opposite and reciprocal. So opposite would become a positive value. The reciprocal of 3/4 would be 4/3. Then we can plug them into our equation using this point and this slope. So we'd have y minus our y coordinate equals our slope 4/3 times x minus the x coordinate. And again, I would just clean this up a little bit. Subtracting a negative, we would write as y plus 5 equals 4/3 times x minus 1. All right, question 14 says, the line y equals 5/9 x plus 6 is graphed on a coordinate plane. A second line is drawn on the same coordinate plane with the slope of negative 9/5 and a y-intercept of 0, negative 6. Write the equation for the second line and describe the relationship between the two graphs. So we have a slope of negative 9/5, a y-intercept of negative 6, so we can go ahead and use y equals mx plus b, our slope-intercept form. So our equation for this second line would be y equals negative 9/5 x minus the 6. It's asking for the relationship between the two. Our initial line had a slope of 5/9. Our new equation has a slope of negative 9/5. Since those are opposite reciprocals, we would say the two lines are perpendicular. All right. Question 15. It says find the x and y intercepts for this function. I'm actually going to put this into standard form first. So I'm going to subtract the 4y over to the left side. And then when we find our x and y intercepts, we are taking turns plugging a 0 in, once for y and once for x. When we plug the 0 in for y, the value we get here will be our x-intercept. And when we plug a 0 in for x, the value we get here will be our y-intercept. So let's look at what happens when we plug a 0 in for y. We'd have 3 times x minus 4 times 0 equals 12. But 4 times 0 is 0, so that's basically gone from our equation. 3x equals 12. When we divide out the 3, we've got x being 4. So my x-intercept would be the point 4, 0. When we plug a 0 in for our for our x value this time, we'd have 3 times 0 minus 4 times y equals 12. Again, 3 times 0 is 0. Negative 4y equals 12. Divide by negative 4, and we get y to be negative 3. So our y-intercept would be negative 3. All right. Our next question. This is actually question 16. We have y equals negative 3x. We are looking at graphing this line. And since it is in basically slope-intercept form, we can graph it that way. Y equals mx plus b. In this case, our m value is negative 3. And since we don't have a y-intercept, we would consider that to be 0. So we would plot a point at 0 on the y-axis. And we need to do a slope of negative 3. So we're going to move down 3 and right 1 and put a dot. Down 3, right 1, put a dot. Down 3, right 1, put a dot. Get at least 3 or 4 points, and then we draw a line through those. Okay, question 17 says to graph the equation y equals 2. Since there is no x, you can think of this as y equals 0x plus 2. In other words, we're going to have a y-intercept of 2, but a slope of 0. That means we're going to rise 0 and run 1. So rise 0, run 1. Rise 0, run 1. What you should be getting is a nice horizontal line here that goes through the y value of 2. Another way to think about that is to just create several ordered pairs that all have a y-coordinate of 2. And you can make up whatever numbers you want and plot those points. You should be getting that same line. Okay? If it had been x equals, say x equals 3, then we're looking at a vertical line here at 3. All right, our last question comes from section 2.5. We're looking at coming up with a line of best fit and using it to make some predictions. So we're going to pull up our graphing calculator here, and we're going to enter our data. Notice from the table of values, we are given a temperature and we are given some ice cream sales. So we are going to put our temperatures as our x values in list 1, and our ice cream sales will be our y values, and we'll put those in list 2. All right, so on our graphing calculator, we go to Stat, Edit. Let me move this up just a tad. All right, Stat, Edit. If you have data in there, remember to arrow up, hit Clear, and arrow back down. Same with our second list. We're going to clear that data out. All right, our values should be for x's 85, 71, 84, 66, 77, 75, 68, and 91. All right, putting our y values in. Paired up with the 85 is 200. Paired up with 71 is 160. And you can pause the recording if you'd like and get these entered on your calculator. Okay. Once you have them all in, we go back to Stat, this time arrow over to Calc, and we want to choose option 4. We're going to move down here to Calculate, and we have our equation. All right, so our line of best fit would have the equation y equals 4.193 times x minus our y-intercept of 163.41. Then it says to predict the ice cream sales when the temperature is 95. Since temperature was our x values, we are going to plug that value in for x. So we're going to put 95 in there. So 4.193 times 95 minus 163.41. Before we do that, I am going to just jot down our correlation coefficient. Our R value is 0.837. So the correlation is going to be positive, and it's fairly strong. It's not great, but it's fairly strong positive correlation. All right, let's calculate our value there. All right, so we had 4.193 times 95 minus 163.41. So ice cream sales would be about $234.93. All right, and that should be a good review for your test.